cells are connected in series. Cells are connected in series. Okay, series combination means, so this is a battery. So battery positive terminal is connected to that one end, negative terminal is connected to positive, then positive is connected to negative, then negative to negative. So this cells are connected in series connection. Okay. So see here, so this these three cells are in the series combination. So negative terminal of the battery is connected to the positive terminal. Negative terminal is connected to positive. Then negative of the terminal is connected to the other end. So this is the external resistance. So external resistance is a positive terminal and negative terminal. So current is flow, charges are flow from the negative terminal to the positive terminal. So see, charges are flow from negative terminal to positive terminal. Current is flow from the positive to negative. That is conventional current direction. So EMF of the each battery. So each battery EMF is E. Internal resistance of the cell is R. So N cells are in series. So total battery EMF equal to summation of I or N into psi. Psi னு சொல்லுவாங்க இதைய. So psi means that is the EMF of the cell. So this is psi of the one battery cell. R is the internal resistance of the cell. இது வந்து ஒரு battery இருந்தா. So now we are connected the N number of cells in series. So summation of I equal to N to 1, summation of I, epsilon I equal to N into psi. So இதை வந்து psi அப்படின்னு சொல்லுவோம். So N into psi. So total internal resistance of the cell. Total internal resistance. ஒரு செல்லோட resistance R. So அப்ப எல்லா செல்லும் என்ன பண்ணிட்டு இருக்கிறோம், சீரிஸா கனெக்ட் பண்ணிக்கிறோம். So when internal resistance இருக்கு, ஒவ்வொரு செல்லுக்கும் ஒரு internal resistance இருக்கு அப்படின்னா நம்ம லாஸ்ட் கிளாஸ்லயே பார்த்திருக்கோம், resistors are connected in series. So the effective resistance equal to என்ன பண்ணுவோம், sum of all the resistance. We have to add all the resistance value. Like that here also the total internal resistance N is added. So the total resistance of N series equal to summation of Ri, I equal to 1 to N. So you can write NR, that is total internal resistance. So here that external resistance is connected to the battery R, that is taken as a R. External resistance is R. So I equal to V by R. See, it is a Ohm's law. Ohm's law, according to Ohm's law, I equal to V by R. V equal to IR or I equal to V by R. V is called total potential. The total potential is taken as N psi. Yes, psi is the potential. N psi total potential psi. Then R is the resistance. Here NR is the internal resistance of all the cell plus connected in the external resistance, that is R. These resistances are connected in series. That's why we are added the two resistance value NR plus R. Okay. According to Ohm's law, I equal to V by R. So the next thing is, so we are going to connect the two cases. So when external resistance R is very large when compared to the internal resistance. அப்போ we are வெளியில ஒரு resistance இருக்கு, internal resistance இருக்கு. Suppose we are connecting the external resistance R very large compared to the internal resistance. So what will happen? So I equal to N epsilon N psi divided by NR plus R. Here R is very much greater than that internal resistance. So what will happen? That NR becomes 0. So flow of current I equal to N psi divided by R. So R is the external resistance. N psi is the potential of all the cells. So the flow of current only depends on the external resistance R. Suppose external resistance very greater compared to the internal resistance. Then next case is, the second case, suppose internal resistance is very much greater than R. So it's a N into epsilon R. This is for first condition. Then the current through the load resistance R will be N times the current sent by the signal cell through the same R. So N times of that cell. Okay.
0 मानते हैं. उसी तरह से आप कोई भी सेल.
So next thing is, cells are in series. So parallel பார்த்துட்டோம். So now we are going to see the parallel connection. So see that cells are connected in parallel. So these three cells are connected in parallel. External resistance is R. So three EMF of the three cells are taken as E, or you can take as is psi. You can say that psi. Instead of psi, we are writing here E. So the R is the internal resistance of the cell. So this is internal resistance of the cell, this one, and second one, and third one. So n number of cells are connected here. So you consider the 2 point A and B between the three cells, right? So number of cells is n, EMF of each cell E, internal resistance of the cell is R, external resistance is R. So internal resistance smaller எடுத்துக்கிறோம், externally connected cell resistance is capital R. So what is the effective resistance? அப்படிங்கிறது நம்ம calculate பண்ணுவோம். So what is the total potential and total resistance? Here the resistance are connected in parallel. So already we know that when resistance are connected in parallel, so what is the resultant resistance or effective resistance? So 1 by R, the sum of reciprocal of all the resistance. இது வந்து நம்ம last classலயே பார்த்துட்டோம். So இதில் இருக்கிற net EMF, so total EMF equal to E. So we are taking that net EMF equal to E, total EMF E அப்படின்னு எடுத்துக்கிறோம். Then next one is the net internal resistance. So internal resistance is taken as R. Net internal resistance means we are connecting the n number of cells. So R is a internal resistance. We are connecting n number of cells. So E1, E2 like that, it will go up to En. N number of cells are connected. So what is the total resistance connected in parallel? That is effective resistance 1 by R dash. R dash is the effective resistance. So we have to add all the resistance value, internal resistance value. So here it is all the resistance are connected in parallel. That's why we are taking that reciprocal of sum of all the individual resistance. So 1 by R dash equal to 1 by R plus 1 by R up to n times, because n number of cells are connected in parallel. Okay. So next we have to calculate the total resistance or the effective resistance. So 1 by R dash equal to, we can take as we have to sum of all the resistances, that is R is in denominator, remaining value 1 plus 1 plus 1 plus up to that it will go up to n. So n times. Then the total resistance equal to n number of cells, that resistance is R. So 1 by R dash equal to n by R, or R dash equal to R by n. That is, we are reciprocal. We are taking the reciprocal on both sides. That's why R dash equal to R by n. Then total resistance. Total resistance means internal resistance plus the external resistance connected in the circuit R. So these are the two resistance. The two resistors are connected in series. See, here all the resistors are connected in parallel, but adding all these resistance, you will get a effective resistance. That effective resistance and R resistance are connected in series. So what you have to do, you have to add the two resistance value. So that current is flowing through that, they are different in the different point B and point A and the resistance R. Here, because of the variation of the resistance, so the total resistance, we are considering that the total resistance means internal resistance of all the cells plus the resistance connected in external. So we can write R plus n by R by n, R by n. So here the two resistors are in series. That's why we are adding the two resistance, internal resistance and external resistance R. So next, I equal to, according to Ohm's law, I equal to V by R. That means potential divided by resistance. Potential here, you know that the total EMF, that is the potential E, divided by the resistance R plus R by N. This is for according to the Ohm's law. I equal to V by R. Here E is the potential. That's why we are writing E by R plus R by N. So first special case. Suppose we are taking that external resistance R is very much smaller than that R by N. So what will happen? We have to put 0 for that R by N. So R is a very smaller value. So R is very much smaller. So R by N is a greater value. So that will become a 0. So you can write R by N. So R by N, or we can write I equal to E by R by N, or we can take up that N into numerator. We can write I equal to N E by R. So this is N number of E by R value. Suppose you are taking the resistance is connected to the circuit, that is battery is connected to the resistance R. So it is only depending on the internal resistance of the cell. It is not depending on the external resistance capital R. That is the meaning for the special case 1. Okay. So I equal to E by internal resistance R, because R is very much smaller. So that is a special case. We are comparing the value of R and R by N. R is the external resistance, R by N is the internal resistance. So in this circuit, I equal to E by R. So only we are considering the internal resistance because that is greater than the external resistance R. யார் இப்போ மைக் ஆன் பண்ணிக்கிறது ஆஃப் பண்ணுவீங்க? So when the external resistance is negligible in comparison to the total internal resistance, the current due to a n number of cells connected in parallel combination is n times the current due to single cell. So that is the equation for this one. Next one, special case 2. Suppose here first one is R is very much smaller. Now we can take R, capital R, that is external resistance, very much greater than R by N. So what will happen? That equation I equal to E by, so R by N is very small. So we can take it as a 0 in that equation. So we can write I equal to E by R. According to the Ohm's law, I equal to V by R, like that. So here that R by N becomes 0 because that is very small. So that's why I am writing I equal to E by R. So first equation, in this circuit, here internal resistance is very small. So that flow of current only depending on the external resistance R. So you can write I equal to E by R. So which resistance is greater? We can take that. We can take that into equation. Okay, so this is called cells are connected in parallel, and these are the two special cases. So when the internal resistance is negligible in comparison to the external resistance, the current due to number of cells connected in parallel combination is same as the current due to a single cell. So when the internal resistance is negligible, therefore when external resistance is very much greater, that is a special condition for the second one. So N times current due to a single cell. So here I is a current due to the external resistance, a single cell. So here up to that we complete the cells are in parallel.